Welcome back to my channel. Today we are going to solve integrations of by parts, which we have to adjust the terms. Okay. Now here question is what? Question number 1 is a log x upon x plus log x the whole square. Now which one we have to choose first function and which one you have to choose second function is very difficult. Okay, over here. Now think of, if you try u equals to 1 plus log x this part. Okay, what comes it? Let's see. 1 plus log x is implies dx equals to 1 by x dx, du equals to 1 by x dx. Okay, now here we have only du over here. Okay, so I need to get x over here. Okay, I need to get x over here, but x is extra over here. Okay, so forcefully we need to keep x over here, therefore this x need to cancel with this x. Okay, therefore if I consider, okay, if I consider whole this can be written as, x into log x into dx upon x 1 plus log x the whole square. Okay, now this can be this and this, which one we have to choose first and second function. Okay, now over here, okay, now integration of this looks nice because over here when we substitute 1 plus log x, okay, and we will get du over here and it's easy to integrate over here. So let's keep this is second function and this, let's take this is first function. Okay, now the integration of this will come since it is second function as well as integration. Let's solve this integration first. Okay, now what is integration of dx upon x into 1 plus log x the whole square. Okay, now if I substitute this, okay, this equals to dx by x become my u integral, and 1 plus x is what? U square. This is same as u raised to minus 2 du is minus 2 plus 1 u raised to upon minus 2 plus 1. Okay, this is integration. Okay, this is same as minus, here we have minus and here we get 1 by u plus c some constant. What is u? U is what? 1 upon 1 plus log of x plus c. Okay, now integration of this is what? Integration of this, we are getting this directly. You can write integration of this is here. Okay, now let's apply integration by parts. This is equals to, first function keep as it is, x into log x, and then integration of this. Okay, integration of this is, we have this minus 1 upon 1 plus log x, okay, minus, okay, integral d by dx of this. Okay, differentiation of this u into v rule. Okay, here d by, here we have to apply u into v rule. Okay, since it is first function, so x d by dx of log x is what? 1 by x. Okay, here, and then plus, and then log x d by dx of x is what? 1. Okay, into integral of second function. Okay, integral second function is, this is, we have this minus 1 upon 1 plus log of x whole dx. You can say over here, I will keep bracket over here. Here minus become plus, this minus I will take outside. Here I can say minus x into log x upon 1 plus log x. Here minus plus, we are getting this gets cancelled here. Okay, here 1 plus log x will come, 1 plus log x upon 1 plus log x integral. Here we have 1 plus log x. Okay, again here we have 1 plus log x, here 1 plus log x gets cancelled, minus plus, here dx. Okay, plus some constant, here minus x into log x upon 1 plus log x plus integration of dx is what? X plus some constant. Okay, this is the required answer. What we have to do is, this is integration by force, or you can say by adjustment we have to do. Since we are substituting u equals to log x over here, okay, we need x over here. This x needs to cancel over here. That's what we are doing adjustment over here, okay? But this from here, from this part you can use by di methods, okay? And this can be integrable. You can keep like this. Here you can use di. Now this part you can keep as a here, okay? And this part you can keep over here. Same answer you will get it. Now these questions, this integral looks somehow complicated over here, because we have in numerator we have x square as well as here x sin x plus cos x. If numerator and denominator are changed, then it could have been very easy one, okay? Now think we need to adjust some term here which we need to use by parts, by integration by parts, okay? But we need to think some term which is adjusted over here. Now can you think over here this denominator term, okay? Now if I substitute u equals to, let's see, if u equals to x into sin x plus cos x, what is differentiation? Let's see how it comes, okay? Now my du equals to what? Applying u into v over here for product rule. Here x divide dx of sin x is what? We have cos of x plus sin of x, okay? And then divide dx of x is 1, okay? Minus divide dx of cos x is what? Minus sin x into dx, okay? Now this sin x and sin x gets cancelled. Here we have, this is x cos x into dx. This is my du, okay? So here this is dx, here dx, okay? Now so I need to get x into cos x. Here since it is x square, so I will get x, okay? Now let's write this once again. Once rewrite this. This is same as x square is x into x, okay? So x into cos of x dx upon x sin of x plus cos of x the whole square. I am separating this square also over here, numerator as well as denominator. For this x square, okay, for this x square I am writing here x1 over here, 1 plus 1 is 2, but this cos x is extra, okay? So here I can say here cos of x, or you can say 1 by cos is what? Sec x, okay? Here I can say sec x. Now if I consider this term and this term, okay? Why? Because the integration of this, okay, integration of this will be easy over here, okay? Now we need to what? We need to choose, this is a second function to integrate and this is a first function for integrate, okay? Now let's solve this first integration separately. What comes for this integration, okay? Integration of x cos x upon x sin x plus cos x whole square. Now if I substitute this become what? X cos x into dx, okay? X cos x into dx become my du upon this become what? U square, okay? Here this same as u raised to minus 2 du is same as u raised to minus 2 plus 1 minus 2 plus 1 is minus 1 by u plus c. What is u? U is what? 1 upon minus 1 upon we have x sin of x plus cos x plus c. Now integration of this is become this, okay? Now this is equals to what? This is equals to, let's write down, this is equals to, by applying integration by parts formula, this is first function, let's keep as it is, here x into x into integration of this, okay? Integration of this is what we are getting is minus 1 upon x sin x plus cos of x minus, okay? I'll break it here, integral dy dx of this, okay? Dy dx of first term, okay? Dy dx of first term is what? X, differentiation of sec x what? Sec x into 10x, sec x into 10x plus, and then keeping x sec x as it is, and dy dx of x is 1, okay? And then integration of second term. Integration of second term is what we have? Minus 1 upon x sine of x plus cos x and dx. Okay, this is our term. Okay, now over here, okay, this is same as I can write here minus x into here sec x upon x sine of x plus cos of x minus integral. Okay, now let's minus plus, I like plus. Okay, here minus and minus plus. Now let's convert everything into sine cos, because here we have sine cos over here. Now x into what is cos sec is 1 by cos, and then is what sine upon cos plus 1 by cos x. Okay, into what we have is x sine of x plus cos of x dx. Now if I take LCM over here, okay, here what we have cos square into sine x. Okay, here we'll have cos into cos is what I'll write over here cos square x. I'll write this x over here. Okay, x this. Okay, now let's take LCM over. If I take LCM over here, this will come what cos square x upon here I'll have cos x. Okay, here cos x. If I take LCM plus. Okay, now this x plus sine x, x sine x plus cos x upon x plus sine x cancel. These two gets cancelled. What I have is I have only 1 by cos square. 1 by cos is what sec square. Okay. Okay, now over here, look at here, we have x is equals to minus x sec x upon x sine of x plus cos x plus integral 1 by cos is what sec square x dx. Okay, now differentiation of tan is sec square, therefore this integration is what minus x sec x upon x sine x plus cos x, and integration of this is what tan x plus c sec square x. Okay, this is the requirement, or you can take LCM or you can keep like this. Okay, now look at this integral. Okay, we have integral of dx upon x6 plus 1 the whole square minus 5 by 6 dx upon x6 plus 1. Okay, now here we have to think something. Okay, we need to adjust some term over here. Now here, can you think over here? We have x plus 6, x6 plus 1 here. We have x6 plus 1 over here. Okay, let's concentrate this part. Okay, in this part, if I substitute, let's see, if I substitute u equals to x6 plus 1, then my d will be what 6x5 into dx. Okay, 6x5 into dx. Good. This, let's consider this part. Okay, let's consider this part. Okay, we'll solve this part later on. Now this integral is same as. Okay, now what I need to adjust here, we don't have anything over here. Okay, this term we need to adjust over here. Okay, let's see adjustment by 6. We need 6x raised to 5 dx upon x raised to 6 plus 1 raised to square. Okay, but this is what, this is extra. Okay, so I need to cancel 1 by 6 is constant, I am taking outside, into here x raised to what, x raised to minus 5. 1 by x raised to 5 is same as x raised to minus 5. Okay, now for this, okay, for this, now if I consider this is what integral part, or you can say second part, and this is what first part. Okay, by applying integration by parts, let's see. First of all, let's integrate this. Okay, let's integrate this. What comes? Integral of 6x raised to 5 dx upon x raised to 6 plus 1 raised to 2. By these substitutions, this become what? This become du upon u square, this same as minus 1 by u plus c. What is u? U is what? Minus 1 upon x raised to 6 plus 1. Okay. Now this, okay, now this is same as 1 by 6 I am taking outside. Now first, okay, first function keeping as it is, x raised to minus 5. Now integration of this is what? This, okay, here minus 1 upon x raised to 6 plus 1 minus integral d by dx of this, okay, here differentiation of this is what? Minus 5 x raised to, here, okay, minus 5 minus 1, okay, into integration of this is this, okay, integration of this is, we already saw over here. Here we have minus 1 upon x raised to 6 plus 1 raised to, we have dx, okay. Here minus 1 is plus, and here minus we have 1 by 6. Here I can say this is same as here minus I am taking outside, here minus 1 upon x raised to 5 into x raised to 6 plus 1. I am writing neat and clean. Here minus 1 is plus, and minus, here I will get minus. Here I have x raised to minus 6, okay. Now over here, this 5, okay, here we have 5, here minus 5 over here, okay, minus 5 minus 5. Here I can, this 1 by 6 I will send inside, okay. If I send inside, then this will be what? Minus 1 by 6. Here will be what? Minus 5, minus 1 is plus 5 by 6, okay. Here this is, I am removing bracket. Here 1 upon 6, okay, here 6 into minus. Now let's send this inside, okay. Now send this is equals to, okay, here minus 1 upon 6x raised to 5 x raised to 6 plus 1 plus 5 by 6, okay. Let's send this inside, okay. 5 by 6 into integral of 1 by x raised to 6 is what? X raised to minus 6 dx, and here plus minus, here minus, okay. We'll get, but we have outside minus over here, okay. See, here we have minus, okay. It was minus 1 by 6, okay. I will keep like this, okay. Let's keep like this. Before, here minus, we already have minus 5, okay, minus 1 by 6. Let's keep like this, okay. Here minus, this is over here minus plus 5 by 6, okay. And here minus plus, again minus, it will be what? Plus, okay, it will be what? Plus 5 by 6 integral 1 upon x raised to 6 plus 1 dx, okay. Now what we are doing is we are solving only this term, okay. We are solving only this term, okay. Now this is, now this term, okay. Now this is for this term, okay. Now this term and this term gets cancelled, okay. We have only this term is equals to minus 1 upon 6x raised to 5 x raised to 6 plus 1 plus 5 by 6. This is x raised to minus 6 plus 1 upon minus 6 plus 1. This and this term gets cancelled. Here minus 1 upon 6 x raised to 5 x raised to 6 plus 1 plus 5 by 6 x raised to minus 5 upon, here minus 5, okay. 5 gets cancelled, and here minus will come, here minus 1 by 6. Here we have minus 1 by 6. If I take minus 1 by 6 common, here again I can take minus 1 by 6 common. Here 1 by x5, okay. 5 plus 5 is 1 by x raised to 10, and then x6 plus 1 plus c, okay. This is the required answer.